All right. Thank you very much for that. As was said, I'm Galen Emery, and I'm here to talk about how to get humans out of production. In particular, what does DevOps and DevSecOps have to do together? So the whole idea here is really focusing on how do we deal with the human threat, the human risk that we see in environments. So first off, who am I? I'm Galen Emery. I work for Chef Software. Chef Software is based in Seattle. I'm based in San Diego because I hate the rain, and so that's why I choose to live down here where it's nice and sunny and warm. I'm currently our lead compliance and security architect, so I focus on our compliance and security posture for all of our customers, for setting up architecture, for setting up the go-to-market, the structure for how we go and sell and manage compliance and security concerns in our customers. I was previously a pre-sales and post-sales customer architect, particularly for the federal space, and I was a global traveler up until about March when everything hit the fan, and I haven't been on a plane in about 5 months, and it's the weirdest experience of my life so far. So what are we going to talk about today? We're going to talk about why this is a problem. Humans suck at routine tasks. What are humans good at? What's better than humans? What can automation prove for us? And we can get into a Q&A. So first, the idea of the human-free pipeline, the definition I'm using here, is the idea that humans do not perform any manual actions past committing to source code management. There's a lot of pieces behind this structure, but the idea here, this is what we're trying to get to when we talk about DevSecOps. We're talking about GitOps. We're talking about security and compliance as part of the pipeline. We're trying to maintain a number of security concerns through our source code management and our change management, and we can prove this through effective source code policy, through effective SDLC. So why is this a problem? Well, it's a problem because humans suck at routine tasks, right? Think about all the things you do on a routine basis. Think about all the things that sometimes go wrong. My most recent example is that I have to grab my keys out of the center console when I get out of my car to come into my apartment building, but I forget 1 out of 10 times. And if I don't realize that I've forgotten before I get through the garage door, then I'm actually locked out of both I can't get back to the garage to get to the car, and I can't get to my apartment because the keys are in the car. So we suck at routine tasks. It's not a good thing for us. And that's just a personal experience, not even a professional experience, not even talking about going through and managing lists of IP address or remoting into a bunch of systems to change a setting, all that kind of stuff. So we suck at them and we get bored and burnt out, right? We don't like to do it. So a lot of people will try to automate this process. But in particular, if you do it manually, you have a potential for mistakes. And again, those muscle memory tasks have errors occasionally, right? There's no guarantee that just because it's muscle memory that you're actually going to do it right the same way every time, every system we touch. So it's really problematic for us to build systems that expect the human to do the same thing over and over and over again. So the reason why this is bad is that if we don't like the work, we get less engagement from staff. If we have manual changes, it means we have manual fixes. Manual fixes mean firefighting style operations where we're spending most of our time dealing with trouble tickets, dealing with outages, dealing with degradation of the service. So we spend all of our time and energy on that. If we have less engagement and we have firefighting, we have greater dislike. We have greater dislike, we have less engagement, and you can see the cycle, right? And those of you who are watching this, you experience this cycle. This isn't new to you. This isn't a new idea that operations can suffer from burnout, right? We see it all the time. And so the problem that this comes into is that we end up with errors and discrepancies. We end up with staff burnout, and we end up with a negative business outcome. The business looks at IT as a cost center, doesn't understand the value they provide to the organization. The consequences of that is that we as an organization are ineffective, and we lose our talent because they go off to better and less stressful environments. So I'm guided a lot of my life by a quote from a manager. He says this to me fairly often. He goes, Galen, you aren't lazy, you just hate inefficiency. And my current manager might just say I am lazy, right? It's we'll see how he says at my performance review coming up here shortly. But the point of this message is that I think that effective folks in operations and in security operations, it's not about laziness. It's about looking at how do we be efficient about solving the problem we're trying to solve. So what are we good at? What are the things that we want to solve? Well, we're really good at design, right? New architectures, solutions to complex problems, understanding how all the SDLC, all these pieces fit together, mapping out the network, understanding the context of the system. Why does the system exist? Why is it important? Understanding the complexity, right? Where can we reduce or eliminate complexity inside of our environments? And the collaboration, understanding the shared purpose and goals, working towards the business outcome. So if I'm a security professional, I'm focused on the security side of the house and focused on making sure that things are secure, but I'm doing it within the structure of the business, right? Understanding that operations and development have their roles to play. They have things they need to get done, and we need to collaborate with them to be effective, right? And same is true for operations, development, QA, finance, pick any group, right? We understand that we're here as part of a structure of solving a business goal. And this is really when we talk about DevOps or DevSecOps, we're really talking about this structure to say, hey, we're going to connect each other to make sure we all understand what the business goal is trying to accomplish and make sure that everything we're doing aligns to that. So these are the things that humans are good at. These are the things we really want to focus our time and energy as humans on, and the focus and energy of the people who work for us on these types of problems. So what's better for the routine stuff? Automation, right? Well, I work for Chef Software. We're an automation company, but Microsoft's been touting this drum for years. Back to Jeffrey Snover with DSC and PowerShell, we really focus on getting the humans out of the manual tasks, right? So for scripting, we want to automate the individual tasks. This is the basic structure most operations teams get into. We write a script to do the thing. We fire off the script rather than going into on the system ourselves. Then we start getting into things like configuration management, right? Keeping the system in your desired state, where Terraform, where the Azure policies, Chef, all those kinds of things come into play. And so we continue down this path towards full automation, right? We talk about infrastructure as code. Now we're talking about compliance as code or governance as code. All these types of things have been just kind of steps towards this overall automation. We want to automate as much of this process as we can get through. And so one of the things that's really interesting about the automation side of the house is that we actually get some security benefits out of it that we may not really be aware that we have. First off is integrity. One of the biggest concerns in the security space is about how do I prove that the thing did exactly what it was supposed to do, the thing is in the correct state, or that the thing only did what it was asked to do and nothing more. Well, we can do that by having an integrity check of the code or the package, right? We have a checksum ability to look at a PowerShell script or look at a Chef artifact or any of that kind of stuff. So we can say, hey, look, I know that this thing is what it is because I validated that it is the exact same on the remote system as it is on my system via crypto, via checksums. So I can know definitively if this thing is the same thing that I built and tested. I have that assurance through the integrity check. I can also establish chain of custody. I can say, hey, I built the code, I built the script, I built the artifact, I built the code to do the thing, and I put it into a pipeline, and the pipeline pushed it out towards production. That gives me chain of custody. I can prove that it went from the source code commit all the way out to production without any tampering in the process by going back to that integrity check. Now, if I take those two principles and I combine them with a removal of user access to production, and if you're an operations person, you're probably sitting there going like, nah, man, I got to SSH, I got to RDP, I have to solve these problems that I have with my environment. And yes, don't get me wrong, there's plenty of reasons for break glass events and other reasons to get into production to make changes to validate the system state. But what we really want to focus on is to say, look, the only way we make standard changes to the environment, and ideally the only way we make any change to the environment, is that we go through the pipeline. And if you're in a cloud native world and you're doing containerization, this is probably old hat to you at this point. But I think it's really important to call out that this is not just a kind of safety guideline inside of the pipeline from okay, yes, I know exactly what the state of the system is because of the pipeline. But really, this is a security principle that allows us to really change the way we think about access control and production. And so the result of these three things together, integrity check, chain of custody, and removal of human access, we get to what we're calling the human-free pipelines. We can say, I don't have humans involved in the process. The automation rules the day. So what is this thing? Really, it's just a set of design principles. Key component here is that the human interaction should be with source code only. The only way that humans get to modify changes to the system is by modifying the code that builds those systems, whatever that code might be. Might be your application code, could be your infrastructure code through Chef, could be things like Terraform, could be your Azure policies. Doesn't really matter what the thing is. The only point is that the human interaction is with the code only. You secure the CI and CD pipeline behind that, then we have a clear chain of custody as we go through. and we sprinkle on top a little bit of removal of human access to production. Again, the only interaction available is with source code. So what does this thing actually look like? This is a basic example of what this thing should look like as a rule. And there's a couple of things I really want to call out. The first is on the left-hand side, straightforward, first step, code review, two-person rule. If you're a security professional, this is a pretty standard rule, right? Two persons, must be, this is the, two people on the keys for the missile silos, right? This is the idea behind that, is that no single individual can make a change to production, right? We spend a lot of time today in operations putting a lot of energy around making sure that when somebody gets into production by remoting into a system or making a change or changing a script, that we've validated that they've done exactly what we asked them to do and nothing more, nothing less. Well, if we could put all of that control, all of that risk management, risk mitigation right here at code commit, that really reduces the complexity of our security posture when we're talking about production systems. If I remove RDP access and just say, nope, the only way you can change things in production is by changing the source code, guess what? I can have one person submit the code for a pull request, and I can have another person review it. And I can set whatever rules I want to set on that. I can make a security professional be the reviewer. I can make preponderance of the team, right? I can make an organizational decision right there and only there about how changes happen to the system. If I don't do this, if I have unfettered access to production, well, then I have to do things like making sure that people have the appropriate account permissions in production. I have to make sure that even with those permissions that I log all their actions so I can check if they're doing something nefarious. I have to potentially in highly regulated environments, I have to set up bastion hosts with over-the-shoulder watching, where somebody's literally watching over someone's shoulder as they're remote into a system to make sure that they're doing the right thing so we can document what they've done, all that kind of stuff. All of that work, all of the audit logging, all the access logging, all the access control policies, all of those things become a much smaller problem, if not gone entirely, the moment I say, nope, the only way that we get anything done is through source code management. So commit code, put code into the pipeline. Then in the pipeline itself, we can do whatever we want to do to validate the code, right? We don't need to make this super hard or super complex at the start. We can just say, look, let's just run some simple syntax checks, some lint tests, and just make sure that we have the basic structure of this code, compiles, does what it's supposed to do at a high level. We can build an artifact. What we want to do then is make a decision once we've built the artifact to deploy the artifact, and that's where humans come into play, right? I don't think CI and CD is a new concept anymore, but what we find is a lot of companies, a lot of organizations sit and go, well, I can't continuously deploy to production because X, Y, or Z. And the whole point of this isn't to say that you continuously deploy to production, but to have a pipeline that has no human steps beyond hitting the deploy button, right? The deploy button is when a human says, I'm ready to go to the next environment. I'm ready to test the next set of tests or do the next thing towards production. It is not to say that I continuously make this thing all the way go out to production, right? Though obviously there are plenty of customers and companies that do exactly that. So just to recap on this slide, code commit happens, two-person rule, it gets enforced there, goes through source code management, goes through the pipeline. Humans have the ability to say, move to the next environment, but they're not doing any work. They're not remoting into systems. They're not making any changes. They're just saying, take the built artifact, deploy it to the next environment, test it, and then continue on through that process. And then we secure the whole thing around it, make it a black box so that nobody can get inside of it to make any changes outside of the pipeline. And if we ever want to validate, again, we have those integrity and checksums that we can do to validate that the artifact we built is in fact the artifact that would have been built from the source code if we just go pull the source code down and build it ourselves. So why does this matter? Well, from an audit and compliance perspective, when we're thinking about how do we get through audits, how do we manage systems, how do we validate the integrity of a system, how do we make sure that from a PCI, a SOX, or HIPAA standpoint, that we actually have control over our systems, the actual state of the system is just one part. There's a lot of effort that goes into documenting how changes happen to the system. If the only way to make changes is through the pipeline, guess what I have? I have a documented change path and a documented audit trail already built as part of my code. The amount of work I have to do to prove how those happen to the system is actually very, very small relative to if I just say, oh, well, Susie goes ahead and logs into production and makes a change when we ask her to. Well, if we say that, then we go, okay, how do we validate that Susie made the right change? How do we validate that she didn't make other changes that she wasn't supposed to make? How do we validate that her credentials didn't get stolen and are used by a nefarious actor? Chain of custody is really important from a security perspective. we're really focused on there is saying, hey, think about evidence, right? When police officers pick up evidence from the ground, it has to maintain in their control at all times. Otherwise, it's tainted. We can't trust it, right? So when we're talking about audit and compliance, and we're talking about security, we're really talking about making sure that we have the same structure of custody to validate that the artifact we built is integrous, has the appropriate things inside of it. And the last piece here is that this is all based upon the principle of kind of artifact-based deployment. I'm going to build an artifact that is my policy, either a security policy, infrastructure policy, application policy, kind of whatever it is. And that artifact with an artifact store is the source of truth for production. We see a lot of ransomware attacks. We see a lot of various hacks that go on. And one of the things that I'm always looking for when I see those is, do you have the ability to rebuild production from your artifacts? And if you don't, then you're really, really at risk from a ransomware attack, right? And so this artifact store, this idea of artifact-based deployment of I can rebuild production because production is just an artifact that I store, then we're at a really good space from a security perspective, and really from a reactionary perspective if something goes wrong in production. So quick recap, humans suck at routine tasks. We really are bad at them. Even the best of us, we get bored, we get distracted, we get halfway through. Following checklists, following those things, they're just not great for us. We are really good at design. You have really good people inside your organizations, really focused on the design, managing the complexity, the collaboration, the business outcome. Robots are really great at routine tasks. Robots must be designed by humans, though. So we must put our robots to use solving the routine tasks. Robots plus security equals a human-free zone where we can remove the humans from the structure. And the human-free zone gives us an attestation on security and compliance state of the system. So we can really attest, we know the state of the system, we know how it got there, we know who made what changes, and we know what those changes affected, right? We know all of that because we can look at production, validate the production's state we expect it to be in through testing, particularly functional testing and integration testing, and we can validate that those are the things that we deployed through the artifact-based pipeline that we've built. That's all I had to present. Is there any questions?
Feel free to come off mute if there are any questions. In the meantime, I will check the event post to see if there are any questions there. I don't see any questions in the chat, Galen. But I must say that the presentation was super awesome and great energy.
Thank you.
So, well, I believe if there are no any questions, then probably we can wrap up a bit earlier. So thank you so much for your time, and thank you everyone for joining. Make sure you come again for the third episode of the Thought Leadership series. I will actually drop the link in the chat, and recording of this presentation will be available if anyone wants to check it out and have a recap. So I will conclude the recording, Galen. So hope to see you soon.
Thank you. Have a good day.
You too. Bye.